Thanks for clicking on the video. In the last episode, we created this face on top by reusing the existing curves. We chopped it up, reusing all the existing cut points and line segments. And then we blended the corners with the same edge blend that we've already used before. And then we created these four new objects here, which unlike the dark blue surfaces which have four sides, this object can handle three sides, or four sides, or five sides, or even six sides, even though six is not recommended. So right now I'm going to take these guys, I'm going to change their color to maybe this. Let's see, what does that look like? Yeah, okay, so this flags them as being different from the dark blue ones and different from all the other ones. Pretty soon I'm going to make this color automatic when you create these objects. Just haven't done so yet. And it worked, and you saw like, okay, so this one they all have a defect, and this one here is very noticeable right here, but this one was not very noticeable. So there are legitimate uses for this relatively simple objects. Let's do an extremely lazy sorting here. I'm going to make a new folder. I'm going to call it lazy, and I'm just going to grab all the stuff we created last time and just dump it in here. Because I mentioned we only have three new element types. So to sort that all, we only need three folders, and they already have places to go in all of this. But there is one thing I didn't do last time, which we have to do now, and that is we need to look at what happens with the cut points. Because these faces used to be independent. Like the two faces on this side had cut points that followed in this direction, but they were not doing anything to the cut points on this side. Now the cut points that go across this top surface here have to match, at least for the time being. This is something that I have a pretty simple solution for, but it will be very annoying to code. So I will do it, I don't know when. For now, let's make it so that this model is editable. First, so to understand the situation, we will break the model. I will go to this point right here, which is at 0.75. I'm going to say, well, what if this guy is 0.9? And I update. Okay, the blue lines are happy because they know nothing about what's going on the cap. And this cap is okay because we adjusted its cut point. What's happening on the other side? Oh, on the other side, things are no good. On the other side, the bottom is still flowing. See, the cut from the bottom is still coming from this point right here. So it went all the way to the top, and nothing was able to adjust at the top because it didn't know that it was supposed to come in at this point. So that's one area where we have to fix it. And let's adjust the other one here. This one was at 0.25. I'm going to put it at 0.4. Okay, so this side here adjusted no problem. Well, because we just changed its cut point. So right here, things are okay. Like, we still have the defect, but things are following each other. But look, on the other side, it's still trying to do the job with this independent point. So it comes all the way up to here, but then I have a mismatch right here. I'm going to do the same. So, okay, so I just adjusted the 2 points on this edge, and now these guys here are not good anymore. I had too many things selected. I just want to edit this point here, and the point color, I'm going to give it the follower color. That's one we need to fix right here, the big blue, the big pink one. And then this one here, come on, let me select it. It's so tricky. Right here. This one here is now going to be a follower. But we also need to do it on this edge here. So I'm considering these are going to be leaders and these are going to be leaders because I'm still working from the bottom left, going counterclockwise. I'm going to keep these two as leaders and these two as leaders. And the ones on this side will need to follow and the ones on this side will have to follow. Let's start by breaking the model with this one as well. And so the first point I'm going to put at 0.4. And this one here I'm going to put at 0.9. Okay, and did that break things? Yep. This face adjusted. This corner here was able to adjust. This corner here was able to, actually no, this corner here was able to adjust, but this entire face is broken and now everything is busted on this side. Okay, so which ones will we be matching to the two that I just changed? It's these two right here. Let's flag them by color. Oh, it doesn't want to let me adjust both colors at once. Okay, that's fine. We'll just do one. This one here. Flag it as a follower. This one here. Flag it pink as a follower. Okay, now we are, by making this surface on the top, we are breaking the rules of the loft. This is no longer a loft. When we created the original curves, we made them all go counterclockwise. And so these cut points are based on this, the values of these cut points are based on this counterclockwise direction. What this does now is that this edge runs this way, and left to right, and this edge in the back runs that way, right to left. So when we match these points, I want this value here to be correct over here, and this value here to be correct over here. But the curves are going in opposite directions. So how am I going to do this? Let's start the naive way. Actually, I need to work. I can't do this from the view sets. I'm going to hide the lazy folder. We're going to go right here because I want, when I link the names, remember that I copy paste the name and I put them in a formula. So I need to be looking at the real points. I want to transfer the value of this guy. So I'm going to copy its name and I want to transfer it to this guy. But the curves they are on run in opposite directions. So actually, before I do that, let me change things a little bit here. I don't want to look at the final surfaces. I want to look at the primary curves and primary surfaces. Okay, so I just copied this value at 0.4 and I want this position to apply to this point in the back here. What happens if I just make them equal? For this point, I go to its value here, I type equal to open the expression editor. I paste the name of the object from the leader. I click here, I type U because U is the parameter that I want from this object. I go OK. I type OK, and what's going to happen if I refresh? You know, either hit refresh here or type F5. Oh, look, it jumped over there. Because this curve is running in the opposite direction, 0.4 on this curve is over on the right side, not on the left side. Maybe I should have put the value of this point here onto this point here, but no. Because remember that we want this to work for all the points along the curve. Not just the one on the bottom, but also its followers. So right now, these points here follow the point on the bottom. And I don't want to edit all those formulas. I only want to adjust the one on the bottom. So it becomes a secondary leader, so to speak. Here is the formula that actually works. I'm going to find that point. It's this guy right here, and I know because it's driven and it's 0.4. I'm going to type equal. I get its formula. The way I get it running in the right direction is I type 1 minus. This is how I reverse the reference of the end and the beginning here. I don't want to adjust everything else. I just want this point here to correctly match this one, and I don't want to edit all the other formulas, so I type 1 minus. Okay, F5. And that worked. This point here feeds its true spatial position to this one. So 0.4 on this one has become 0.6 on this one through the use of a formula. And because I did it this way, the points that were already following this one also follow correctly. Let's test that. This guy here, I'm now going to set it at 0.1. Hit F5. This point is now at 0.1. This point here follows correctly, and that means that it has a value of 0.9. But all the points that are already dependent on it are following correctly. So that's the pattern. Because we have added this face at the top, which cannot follow the order of our loft, and remember, the loft was never real. The loft was just an appearance. Now I have to adjust these formulas. Okay, here's this. Let's do this one. Steal the name. Right here, I want to apply it to this one. Equal, type in the name, select the object, type U, select the parameter, and now 1 minus. Hit F5, and both of these points are now updating correctly. Both of the large pink points are now updating correctly to follow these guys. Let's just finish this. I grab this one, I grab its name, I'm going to apply it right here. Equal, paste, confirm object, type U, confirm parameter, 1 minus. There's an infinity of ways you can set up these points. You need to know what you want. Look, this point here has shifted to 0.4. Now this one follows automatically to 0.6 because their curves run in opposite direction, and all the ones above follow correctly. Let's do the last one. This guy. No. The point right here. Copy. This guy here. Equal. Move the window so you can see it. Paste. Confirm the object. Type U. Confirm the parameter. 1 minus. F5. Okay. Let's go here. Hide the full surfaces. Hide the curves. Show the final surfaces. And everything has snapped back. Because we added this surface at the top here, we have to force the opposite sides of our loft to follow each other. Remember, I intend to eliminate that restriction, but that's the restriction right now. Let's go this one to 0.1, F5. So now we're going to have everything at 0.1, 0.9. Here we go. Now look, and by reducing the blend, I still have a defect right here, but it's very small. In some circumstances, this will be good enough. In some circumstances, it won't be good enough, and we'll fix it. Okay. Let's stop being lazy. Let's organize this stuff pretty quick. Control grids. I'm going to show everything that's in here. This control grid here is a primary set of thing. It goes in this folder. I hide it. This control grid flow, it goes into the flow grids folder. I hide it. Then this cubic surface. This cubic surface is a primary surface. So I put in the cubic surface folder of the primary curves and surfaces. Show them all, hide them all. These control edge segments, these are pieces of the grid. That belongs in the blending setup. But there's two types. There's edge grids to restore and edge grids to blend. So the first one is the one in the middle. That is a surface to restore. That's a grid to restore. I put it in here. Show them all, hide them all. These four pieces, these are edge grids to blend. I hate how it moves the folder. I really wish it didn't do that. Edge grids to blend, show them all, hide them all. This right here, hold on. These are edge grids to blend. Then I created the restored surface. That is actually part of my final surfaces. It goes into this folder here. Restored surfaces. I hate how I have to scroll back. Sorry about that. I don't need this anymore. I don't need this anymore. I'm still in the blending setup though, because now that I've sorted out my restored surface, these are my actual edge blend grids. I put them in the blended edge grids. Show them all, hide them all. Now here, these four, these are part of my final surfaces, blended edge surfaces. Show them all, hide them all. I've dealt with all of that. Blended edge surfaces, yep, that's all of them right here. And here, these corner blend surfaces, well, that actually, we can put these subgrids in here. But let's first look. Here we have corner subgrids. These are standard corner subgrids, and these are the standard corner blended grids. But we could put these subgrids in here. So here I have 1, 2, 3, and then 1, 2, 3, and then 1, 2, 3, 1, 2, 3. We could differentiate them from the ones that are used to make from the subgrid 3 3s, but all I said here was that these are corner subgrids. I didn't say that this was a folder for only 3 3s. So I'm going to collapse it so I can see what I have below. I have all the subgrids for all four corners. I'm going to put them here in my corner subgrids. I don't actually need a new folder for this. And then here I have the full grids for my 4 corners. Well, these are corner blended grids. Right now they're using this different type of grid, but this folder is already a good place to put them. Corner blended grids. So here, now I have all my edge grids to blend. I've sorted them. All my blended edge grids, I've sorted them. All my corner subgrids, even though they're different types of subgrids, it's fine to have them all in one folder. All my corner blended grids. Yeah, they're a different type, but they can all go into this folder. And then these last 4 right here, I can just put them in final surfaces, corner blend surfaces. They're not the same type of surface, but they fit really well in this folder. So here, I've sorted everything in the lazy folder. I just deleted. I didn't need to create any new folders to sort all this stuff. I forgot to hide something. I forgot to hide this folder. So I'm going to do that. I'm going to, it's because I put it in the wrong folder. This here was supposed to go into my control grid 4/4s, not in with the control polys. So I put it in there. I show all my standard grids. I hide all my standard grids. I didn't create any new control polys for what we did. And here are all my flow grids. All the standard grids with very hard corners, and all the flow grids. I didn't create any new points on curves. Everything fit into here. Before I save the file here, You remember I had turned the visible edges on these surfaces here when I was using them to create the simple cap using the part workbench. I'm not going to be doing that anymore. I'm not going to be using that simple cap. So I'm going to take all of these and put them back to the shaded value. Someone in the comments for the video when I made the flat cap using the part workbench said that filling surface is parametric. So if you use that tool, it could close the bottom parametrically. So you're welcome to try that. What I found is that object often breaks. I use it, but only at the last minute because it often breaks. And since it's harder to use than the shape builder, I need to do more testing before I recommend using it all the time. But you can go ahead and do that. All right. Personally, I don't care right now. I want to go back to pure silk, so to speak. So here we are. Our cap that we created last time, we synchronized the points on the bottom. Actually, you know what? I'm going to give these points here a different color because they are still leaders in a way. They're leaders for this part of the loft, but they're not leaders because you don't assign their value directly. I'm going to give that a different color. I'm going to give it that, I say that bright orange, right? So because we have a single face across the top, we're not using a standard CAD trick to fill this. We are literally using silk to blend across this non-standard topology. So I'm going to flag those differently. You see now that how many totally free points do I have available to control these cuts? Well, now I only have 4 for the bottom section because this bottom section is a face of its own. So it forces left to right alignment and top to bottom alignment. And I still have 4 cutting points along the length of the loft. All right, that's it for the cleanup phase. Next time we will create our first truly three-dimensional curve that is not just a straight line. Because these are truly 3D. I mean, these are not in any easy plane. They're not in X, Y, Y, Z, or ZX. But they're also boring because they're straight lines. Next time we'll make our first truly interesting three-dimensional curve with curvature in many directions to sculpt this cap. I'm going to save as right here, and that'll be it. Save as. 69 silk cap cleanup. All right, catch you next time.